Hello everyone and welcome to Architecting a Company in Azure. This training session will help build our pre-sales technical skills by working through an IaaS solution with particular focus on correctly sizing and pricing the components required. My name is Daniel Baker and I'm a Partner Development and Learning Specialist here at Microsoft, or now perhaps more commonly known as Azure Dan. I have a 20 years experience in IT, 17 of which as a Microsoft certified trainer for leading learning partners, and I have a strong specialization in Active Directory, core infrastructure, and both public and private cloud technologies. It's my wish that you find this training helpful, and while my aim is to keep it as high a level as possible, I still want people who view this course to be able to walk away armed with the information required to be able to better understand and correctly price your client solutions. If you have any questions or feedback, then please reach out to me because I'm always happy to hear from you. The two most frequently asked questions when moving to an Azure IaaS solution are, how do I size the machines and how much will it cost? Let's address these questions by working together to understand the components needed and the tools available. By the end of our session today, you will feel more comfortable using the Azure Sizing tool and online calculator. We will break the session down into the following topics. First, we will understand the components of our solution, including virtual machines, storage, network, and protection, and then we will investigate how we size and price the solution using the tools available. Finally, we will assess our knowledge by working through a case study. Before we start, I have to do the disclaimer thing and remind you that prices are correct at the time of recording and fluctuations can be due to the type of subscription you are using and the region in which you are deploying the resource. With that said, let's begin. Let's begin with virtual machines and pricing. Now, Azure Virtual Machines are one of several types of on-demand, scalable computing resources available in Azure. Typically, you'll choose a virtual machine if you need greater control over your computing environment than other cloud services offer. An Azure Virtual Machine gives you the flexibility of virtualization without having to buy and maintain the physical hardware to run it. However, it's important to note that you will still need to maintain the virtual machine by configuring, patching, and maintaining the software as necessary. Some use cases include development and testing, running applications, extending the data center, and disaster recovery, with images being provided by Microsoft, their partners, or your own generalized builds. When selecting a virtual machine, there are many considerations to take into account. These include the operating system that you wish to run, the number of virtual machines that you wish to provision, the storage and disk IOPS required for the solution, and the total hours that the machines will be active. Microsoft offers one of the largest selections of compute tiers on the market, each with differing capabilities reflected in the pricing model. In the following slides, we will discuss these capabilities in more detail. Let's begin with the basic tier in the A-Series family. These virtual machines offer an economical, low-cost solution for testing and development purposes and not recommended for production workloads. It's important to remember that all 5 instances of these machines are throttled to 300 IOPS per disk and will not offer load balancing, auto-scaling, or memory-intensive configurations. Moving to a standard tier offers more options. This includes an increase to 500 IOPS per disk, internal and external load balancing, and money-saving flexibility with auto-scale capabilities. There are also specialized instances, such as the network-optimized A8 and A9 builds that both offer 32 gigabit InfiniBand network connectivity for high bandwidth, low latency data transfers, in addition to the A10 and A11 builds that are optimized for high performance clusters, video encoding, and compute-intensive scenarios. Some workloads, such as databases, have a disk-based cache, and you can greatly increase the performance of dependent applications by placing this cache onto the local solid-state disk offered by the D-Series virtual machines. These machines are positioned for IaaS deployments, but can also be used in web and worker role builds in Azure Cloud Services. In addition to this, the D-Series virtual machines offer 60% faster processors than their A-Series counterparts and are ideal for applications that demand higher performance from the processors, RAM, and general throughput. Building on the success of the D series, the DV2s are the next generation builds that can also be used as virtual machines or cloud services. These machines are equipped with the latest generation Intel Xeon processors and offer a 35% performance increase while carrying the same memory and disk configurations as the older models. Because of this, the DV2s are an ideal solution for many enterprise-grade applications. The F-Series virtual machines are configured for compute-optimized, low-memory deployments and support 2 GB of RAM and 16 GB of local solid-state disk per CPU core. Personally, for me, this tier represents a much simpler understanding because the numeric value after the series letter now actually represents the amount of cores you're getting. I realize that this was a cause for confusion and pleased to say that moving forward, all new tier releases will adopt this model. The F-Series can achieve clock speeds of up to 3.1 GHz and are a smart choice for batch processing, web, analytical, and gaming scenarios. Next, we'll look at the recently released N-Series builds which have just gone into public preview. These machines are enabled with NVIDIA's cutting-edge GPUs and split into two categories. With the NC series, which are compute-focused GPUs, you'll be able to run compute-intensive HPC workloads using CUDA or OpenCL. This SKU is powered by Tesla K80 GPUs and offers the fastest computational GPU performance available in the public cloud through discrete device assignment technologies, which results in close to bare metal performance. In addition to this, the NV series focuses more on visualization and utilizes Tesla M60 GPUs with NVIDIA Grid technology for desktop accelerated applications and VDI. This allows you to visualize graphic-intensive workflows and run single precision workloads such as encoding and rendering. Finally, the G series offers the latest Intel Xeon processors, twice the memory and 4 times the solid-state storage of the DV2 tier, which makes these machines the ideal choice for your most demanding applications. A common question asked by customers is the storage included when you size the virtual machine? Although all tiers document the disk size, it's important to realize that this disk is simply the temporary, volatile volume included for the running of the machine. This disk should not be used for anything other than the page file and performance caching operations. Therefore, when you consider the costing of a VM solution, you will need to take into account any additional OS and data disk charges. And I realize that this is a cause for confusion. Why don't we just package it all under the VM? But when you think about the myriad of configurations that you can have with storage accounts and the replication topologies in addition to the disk size and I/O speeds, adopting this model allows customers to tailor the solution to their specific needs and moves away from a one-size-fits-all mentality. We will look at disk and storage types in the next section of this course. Okay, so let's jump into the portal and take a look at machine tiers and prices. So from our portal, let's go ahead up into new, and from our marketplace, we're going to search for a Windows Server 2012 machine. I'm going to select the 2012 data center. That will change focus into our marketplace image, and I'm going to deploy using Resource Manager. From here, I've got 4 headings that I need to fill out should I wish to deploy this machine. I need to fill out the first one so we can get to the sizing. So let's quickly give this a name. So Azure Dan VM. We're going to choose a solid state disk. The username is going to be Daniel, and I will put in a password. And quickly confirm this password. From there, I'm going to create a new resource group called Azure Dan Demos, and from here we're okay. Now, this is the bit that I wanted to show you. As we come down into size, we'll just wait for this to load. You can see that it's suggesting the DS machines, but if I go into View All, you can see that I've got a selection of builds. Okay, so I've got DS's in there, I've got G machines in there, I've got F series machines in there. You'll notice that I don't have any A series machines. Now, the reason I don't have any A series machines is if I go back into basics, it's because I selected this solid state disk and we said that the A series can't support that. If I now drop down into a basic hard disk and say OK, and then go back into size and view all, as we scroll down, you can now see that we've got these A series machines in there and we've got much more choice. Okay, so just be aware as you navigate through the portal, it depends on the disk structure that you choose, which defines what you will see in these machine placements. With that said, I'm going to go ahead and let's look at a DS4 V2. So a DS4 V2 will give me 8 cores, 28 gigabytes of RAM, up to 16 data disks. Now, if I connect those data disks together, it will give me a combined IOPS of 25,600. I've got 56 gigabytes local SSD, and if you remember, that's that volatile storage we spoke about. This particular tier supports load balancing and also has premium disk support for that solid state disk. So if we close this down, let's just quickly close these down and jump into our pricing. Under Azure.com, we can see under pricing, we've got virtual machine pricing. We can see that we're billed per minute. We're only paying for what we use, and there are no upfront costs. So as we come down, we can see, as I showed you on the slide deck, all of the different costs associated with these machines. If we then jump into the pricing calculator and add an item, we can come down into compute. We can add a virtual machine. And we can see the virtual machine is now added. If I come down, you've got virtual machine in there. But do bear in mind, what we will also need to do is we will need to go in and we will need to think about the storage that we're going to be using. Okay, so as we start to build this solution, and we'll come back and visit this later on in the course, but you need to be aware of all of the components that you need to add to it as you start building your customer solutions. Let's now take a look at the storage options offered by Azure. Cloud computing enables new scenarios for applications requiring scalable, durable, and highly available storage for data. In addition to making it possible for developers to build these large-scale applications, Azure Storage also provides the storage foundation for Azure Virtual Machines. Azure Storage is both elastic and massively scalable, allowing you to store and process small amounts of data for a company website, up to hundreds of terabytes of data required by scientific, financial, and media applications. This enables the design of applications for large global audiences, which adapt with auto-partitioning systems that automatically load balance your data based on traffic. So where are we today? To date, Azure Storage stores tens of trillions of unique customer objects and handles millions of requests every second. With its best-in-breed elasticity, you can design applications for large global audiences which scale as needed. This is both in terms of the amount of data stored and the number of requests made against it, all the while only ever paying for what's consumed. The auto-partitioning system employed by Azure Storage automatically load balances your data based on traffic. This means that as your demands on your applications grow, application storage automatically allocates the appropriate resources to meet demand. Furthermore, Azure Storage is accessible from anywhere in the world from any type of application, whether it's running in the cloud, on the desktop, on an on-premises server, or on a mobile or tablet device. In the next slides, we will discuss the different types of available storage. Blob storage, sometimes referred to as object storage, stores unstructured data such as documents, media files, or application installers. Similar to your existing general-purpose storage accounts, they share all of the great durability, availability, scalability, and performance features that we're used to today. This includes 100% API consistency. This particular storage service in Azure offers 3 types of blobs: block blob, append blobs, and page blobs, which are specified during creation. Block blobs are optimized for streaming and storing cloud objects such as documents, media, and backups. Page blobs are optimized for infrastructure as a service disks, supporting random writes, and append blobs are optimized for append operations such as log files. The table service is Microsoft's NoSQL key attribute store utilized in a tabular format to store flexible datasets. This includes user data, address books, device information, and many other metadata types. Tables store data as collections of entities which are similar to rows. Each entity has a primary key and a set of properties that uniquely identify it, along with a timestamp that's used to track when the entity was last updated. It's important to note that the table service doesn't enforce a schema by default, which means that two entities in the same table may have different sets of properties unless enforced from the client side. Azure Queues provide a reliable messaging solution for asynchronous communication between application components. These could be running in the cloud, on a desktop, on an on-premises server, or on a mobile device. Messages typically have a small body with attributes such as a time to live, which are used for configuring the service and representing tasks created by the front-end producer, which in turn are processed by a back-end consumer. Finally, Azure File Storage offers cloud-based encrypted SMB file shares, allowing customers to easily migrate legacy applications to Azure quickly and without costly rewrites. In addition to this, virtual machines and cloud services can share file data across application components and with on-premises applications via a simple file service REST API. Azure File Storage offers availability, scalability, and geo-redundancy, allowing you to confidently store your server data, log files, event data, and backups in the cloud. But what does it all mean? Let's try and put this into perspective. One of the largest and most recognizable adopters of Azure Storage is our own Xbox Live service. As you can see in the deck, we use a combination of binary large objects and table stores to log activity feeds, achievements, friend lists, and matchmaking solutions on a highly scalable, efficient, and reliable platform. When building a solution, it's important to be aware that Azure Storage offers a number of performance tiers, each of which are tailored to a specific business need. Azure Premium Storage delivers high-performance, low-latency disk support for I/O-intensive workloads running in Azure virtual machines. With Azure Premium Storage, you can attach multiple persistent data disks and configure them to meet your performance requirements. Standard disks are ideal for cases where consistent, low latency and high throughput are not required. You may use standard disks as a more economical option to their premium storage peers. Standard disks support all of the features of premium disks but run under a lower IOPS SKU. Finally, Core Storage offers a low-cost solution for object data that is infrequently accessed, including backups, media content, scientific data, and archives. Generally, any data that requires long-period storage and is accessed less than once a month is a strong candidate for Core Storage tier. The pricing for the standard tier of Azure Storage is as follows. These costs reflect different redundancy SKUs which will be discussed in the following slides. It's also important to be aware that the transactional charges are applicable for a nominal fee. Currently, we have three service types for our premium disk offerings, the P10, P20, and P30 configurations. These disks are not subject to transaction charges. The data in your Azure Storage account is always replicated. This ensures durability, high availability, and meets the SLA for storage even in the face of transient hardware failures. Over the next slides, we will examine the different replication options and discuss scenarios for use. Locally redundant storage maintains 3 copies of your data, which is triple replicated within a single facility and within a single region. This replication topology protects your data from normal hardware failures, but not from the failure of a facility, meaning that in the case of a regional disaster, data access could become compromised. Locally redundant storage is a great candidate for testing scenarios where enhanced, highly available data access is not critical. Because of this, LRS is offered at a discounted rate. For highly available production requirements, we recommend a geo-redundant storage solution. Zone redundant storage maintains 3 copies of your data, which is replicated 3 times across 2 or more facilities. This can be either within a single region or across 2 regions. Zone redundant storage is currently available for block blobs only and provides a higher level of durability than LRS. Geo-redundant storage maintains 6 copies of your data. With GRS, your data is replicated 3 times within the primary region and a further 3 times in a secondary region hundreds of miles away. This SKU provides the highest level of durability and therefore recommended by Microsoft for highly available critical production workloads. Our final replication SKU is read access geo-redundant and is enabled for your storage account by default. Read access geo-redundant storage replicates your data to a secondary geographic location as per standard GRS, but also provides read access to the secondary data for certain workloads. So let's jump back into the browser and take a look at some of the storage options and associated prices. So from our portal, let's go ahead and build a storage account. So I'm going to look for a new storage account. And that should change focus into my marketplace. And again, I'm going to go ahead and select this top option and go ahead and say create. Now from here, when this blade opens, it's going to want a name for the storage account. It's going to want to know the deployment model, and obviously we're going to be using Resource Manager. But then it wants to know the account kind, and you'll notice there's two types. There's general purpose and there's blob. Let's leave it at general purpose to begin with. But under general purpose, I have the option to choose a standard or premium SKU. I then have the option to choose the option that I want to select for redundancy. And you can see by default, it's read access geo-redundant storage, but we have geo-redundant storage, locally redundant storage, and zone redundant storage options to pick also. If I then go back up into blob storage, you can see that I have the option, again, to choose my replication topologies, but also to choose between core and hot tiers. Finally, I also have the option to choose whether or not I want to enable server-side encryption. So with that done, let's go ahead and jump into Azure.com to understand the pricing. So under Azure.com, I've clicked on pricing. I'm going to come down under data and storage. I'm going to click on storage. And then from here, standard information, no upfront cost, no termination fees, pay for only what we use. We then have information on the different replication topologies, as well as information on the different storage types. So we talked about blob storage, disk storage, table storage, queue storage, and file storage. Okay, if we look at the information below, we can then see the storage prices and the access prices, and also information about large import and export operations from the Microsoft Cloud. If I go across to the pricing calculator and add items, if we come down under data and storage and click on storage, we can then see that we have the option to go in there, choose the region that we want to be in. So if I go ahead and say West Europe, the type of storage service that I want. So I'm going to say a block blob, the pricing tier, the redundancy, and whether or not it's hot or cold. From there, we've got the capacity, the size that we want, put operations such as put, list, create, container, any other operations, and then we can put in there data write services and data retrieval. When building and designing Azure solutions, it's important to consider the connectivity and routing options that are available. Over the following slides, we will investigate the key components and solutions offered to ensure secure and consistent connections into production workloads. In modern ARM-based deployments, virtual machines require hosting on Azure Virtual Networks. An Azure Virtual Network, or VNet for short, is a representation of your own network in the cloud. It is considered a logical isolation which is dedicated to your subscription and allows you to fully control the IP subnets, address blocks, DNS settings, security policies, and route tables within. You can also connect the virtual network to your on-premises network using one of the connectivity options listed on slide. This can include access via a public-faced IP address on the provision VM, secure tunneled access on an individual machine using a point-to-site connection, or complete site routing via a site-to-site topology. You also have the ability to peer VNets within a subscription to facilitate routing, in addition to establishing a dedicated private pipe for your cloud resources with ExpressRoute. In essence, you can expand your network to Azure with complete control and benefit from the enterprise scale functionality that Azure provides. Virtual networks in Azure are free and have an allowance of up to 50 VNets per subscription. As a rule of thumb, you should ensure that you have created a VNet before deploying any IaaS VMs or PaaS instances into your Azure environment. ARM-based VMs require a VNet. If not specified, Azure will create a default VNet that could potentially have a side or address block clash with your on-premise resources. It is for this reason, correct preparation and IP planning should be part of your initial design consultation. In the following slides, we will examine the different options available with Azure Virtual Networks. A subnet is a range of IP addresses within the virtual network. You can divide a VNet into multiple subnets for organizations and security needs. Virtual machines and PaaS role instances deployed to subnets within a VNet are able to communicate with each other without any extra configuration. You can also configure route tables and network security groups to a subnet to control conditional access. There are two types of IP addresses assigned to resources in Azure. These addresses are public and private. Public IP addresses allow Azure resources to communicate with Internet and other Azure public-facing services. This includes Azure Redis Cache and Azure Event Hubs. Private IP addresses allow for communication between resources in a virtual network, along with those connected through a VPN connection back to on-premise resources. Azure Load Balancer delivers high availability and network performance to your applications by distributing traffic among healthy service instances. Virtual machines and cloud services within a VNet can be exposed to the internet using Azure Load Balancers. For line of business applications that are internal facing, internal load balancers can also be used. Network security groups control inbound and outbound access to network interfaces, virtual machines, and subnets. Each network security group contains one or more rules specifying whether or not traffic is approved or denied based on source IP address, source port, destination IP address, and destination ports. A VPN gateway is a collection of settings that are used to send network traffic between virtual networks and on-premises locations. A VPN gateway is used for site-to-site, point-to-site, and express route connections and supports multiple pricing performance tiers. Each virtual network can have only one virtual network gateway, and the costs involved include both the running of the gateway and any egress data involved. It's important to note that inbound data is always free. The data charges associated with egress data can be seen on the following slide. Prices will vary dependent on zone type and total egress data consumed. US, Europe, and UK markets are identified under Zone 1. So before we jump back into the portal to take a look at pricing, let's quickly talk about Microsoft Azure ExpressRoute. Now, ExpressRoute lets you extend your on-premises networks into the Microsoft Cloud over a dedicated private connection. This allows connections to various cloud services such as Azure, Office 365, and CRM Online from a point-to-point or virtual cross-connection via connectivity provider. ExpressRoute connections don't go over the public internet, meaning that customers can expect more reliability, faster speeds, lower latencies, and higher security than other connectivity models. All inbound data transfers are free of charge, and all outbound data transfers are charged based on a predetermined rate. It's also important to note that users are also charged a fixed monthly fee based on high availability dual ports. Microsoft also offers an unlimited data plan in which all inbound and outbound data transfers are included within a fixed monthly fee dependent on port speed. Additionally, Microsoft offers a premium add-on which offers increased route limits, global connectivity, and an increased number of VNet links per circuit. So let's jump back into our portal and take a look at configuration and pricing options. Okay, so from our portal in our Azure subscription, let's go ahead and look for a virtual network. Okay, so if we select virtual network, it changes focus into the marketplace, and we're going to select the virtual network. Now, if we go ahead and create this, you're going to see there's nothing in there that really focuses on pricing because we said a virtual network is free. This allows us to control our address space. It allows us to define our subnets, our subnet address ranges, and whether we want to put it into an existing or new resource group. If I come back and we then choose virtual network gateway, you'll see that this allows us to connect into an existing virtual network. It allows us to specify a public IP address. It then allows us to choose whether it's a VPN connection or an ExpressRoute connection and the VPN type that we're going to use. If we then close this down, and jump into our pricing. So again, I'm on azure.com. I've gone into pricing, and I'm going to come down and under networking. You can see I've got virtual network, express routes. I've got load balancers, VPN gateways, and so on. I'm going to go ahead and click on virtual network. Now what you'll see is virtual networks in Azure is free of charge. As we said, every subscription is allowed to create up to 50 virtual networks across all regions. Public IP addresses and reserved IP addresses used on services inside a virtual network do carry a charge, however. Okay, we also have this new VNet peering, which links two virtual networks in the same region and enables you to route traffic between them using private IP addresses. Okay, we can see as we go down that public IP addresses and reserved IP addresses that are used in the service will carry a nominal charge, which is outlined here. So if we go ahead and click on there, we can see that we've got different types of IP addresses in there and the pricing associated with it. So the first 5 are free, additional reserved IP addresses, and unused reserved IP addresses. So the costs associated with them. If we go back and we come down to the VPN gateway, again, we've got pricing information that we can go through. So we can see we've got the basic VPN gateway for a VPN or express route, the standard VPN gateway, and the high performance gateway. Okay, if we come down, we can see we've got inbound into VNet data transfers, outbound internet VNet data transfers, point to site, and so on. Okay, so let's go ahead, jump into our pricing calculator, and let's start pricing this up. So if I click on add items, if I come down into networking, let's go ahead and select a VPN gateway. Okay, the VPN gateway has been added, and I'm going to say that this is West Europe. I'm going to say that we want this continually running, so 744 hours. Okay, and we can choose, is it a basic VPN, is it a standard VPN, or is it a high performance VPN server? And you can see the prices change accordingly. So I'm going to say a basic VPN at 16.36 a month. Outbound into VNet data transfers, I'm going to say standard VPN, and I reckon that we're going to do, I don't know, let's say 5 terabytes a month. So again, you've got the charge for the machine and then the bandwidth charge in there as well. And that's particularly high. I mean, 5 terabytes is perhaps a little unrealistic. So if we drop that down to say 1 terabyte, again, you've got the pricing that is displayed for you. Organizations need a business continuity disaster recovery strategy that determines how applications, workloads, and data stay running and available during planned and unplanned downtime. They also need a strategy that allows workloads to recover to normal working conditions as soon as possible after an event. Microsoft offer a number of solutions to ensure a successful BCDR strategy, and in this section we will focus on the 2 predominant technologies, Azure Backup and Azure Site Recovery. Azure Backup allows you to back up data to the Microsoft Cloud. It replaces your existing on-premises or off-site backup solution with a cloud-based tool that is reliable, secure, and cost competitive. It also helps protect assets that run inside the cloud and provides recovery services built on a world-class infrastructure that's scalable, durable, and highly available. Azure Site Recovery contributes to your BCDR strategy by orchestrating replication of on-premises, physical servers, and virtual machines to the cloud or a secondary data center. When outages occur in your primary location, you fail over to the secondary location and keep applications and workloads available. You then fail back to your primary locations when normal operations resume. The new pricing model for Azure Backup has 2 components. Protected instances, which is the primary billing unit for Azure Backup, whereby customers pay for the number of instances that are protected, and the storage consumed, allowing customers to choose between locally redundant and geo-redundant solutions. With this new pricing structure, the backup data stored in Azure is billed at block blob rates for the region, and the 2 components will appear as separate line items on your monthly bill. The total amount of backup data held for a specific protected instance can change due to the following factors. This could include the retention period of the backed up data, net new churn stored in each recovery point, the level of compression achieved on the backed up data, in addition to the frequency of the backup jobs and any associated metadata. Customers should use the Backup Vault dashboard page to show the total data consumed. Microsoft Azure Site Recovery offers a single solution that supports multiple infrastructures and can be used to facilitate replication into a secondary physical data center or the Microsoft Cloud. The technology supports a BCDR solution for physical machines and virtual machines using both Microsoft and third-party hypervisors. Azure Site Recovery is built based on the number of instances protected. Every instance that's protected with Azure Site Recovery is free for the first 31 days, excluding charges for storage, transactions, and data transfers. The following slide lists the costs associated with setting up an ASR solution for both orchestration to a separate physical data center and orchestration into the Microsoft Cloud. Okay, so we are halfway through the course. Up until this point, we have focused more on the technology, but for our second half, I want to focus on the tools that we can use to firstly size the solution and secondly price the components. We will begin by downloading and installing the Azure Cost Estimator tool. The Azure Cost Estimator tool has been designed to provide IT managers the ability to quickly assess the running costs of an existing on-premises workload on Azure. The tool provides real-world machine hardware usage and recommends appropriate Azure instances to match the scan workload. Features include support for multiple technologies including Microsoft, VMware and physical environments, visibility of multiple cloud VM tiers, price conversion for multiple currencies, sample scenarios, cost estimates based on real estate scanning, and exporting of this data to Excel spreadsheets. So let's jump in and take a look at the tool. Okay, so I've already opened the tab. I've gone to Microsoft.com down to the download sites, and I've just searched for the Microsoft Azure Cost Estimator tool. So let's go ahead and download this. And we'll just wait for that to come down. And from there, we'll go through and we'll run the installation wizard. So what I'll do is I'll pause the video and we'll come back when this is installed. And we're back. We can see the tool is downloaded, installed and opened, and now presenting us with two options. The first option invites us to scan our environment. The second option allows us to choose the environment and services we wish to price. So I'm going to go ahead and look at both options. First thing I want to do is I want to go into scan your environment. And you can see that it invites us to scan System Center Virtual Machine Manager, Microsoft Hyper-V hypervisors, VMware vCenter and ESX solutions, or physical machines running either Windows and Linux. If I go ahead and select Hyper-V, for example, it's going to choose the machine type, ask me to specify the IP address and authentication into the machine. From there, I can then choose the profiling duration, the scanning frequency, and the report name that I want to export to. If we go back into scan your environment, and maybe this time choose a physical environment, you can see that from here we can choose Windows, we can choose Linux, or we can scan an IP range. So if I scan an IP range, I'm looking for Windows machines, my start and end IP address, and again, the account credentials to be able to connect to those services. With that done, let's now look at our second option, whereby we can choose our environment and services. So if I go into Start, we can see that we currently don't have any cost estimates. So let's go ahead and add a new cost estimate to begin. From here, we're going to give it a name. So Azure Dan Demo Estimate. I want the currency to be in British pounds. Support, where I have the included support. Again, I've got the option to drop down and choose the type of machines that we're doing it for. So if I say production, and from there, we're just going to put in the account details. So Daniel Baker, Microsoft in Reading, and
my email. Okay, so from here, what I can do is I can now start adding to this scenario. So if I go in there and go, Azure Dan demo, if we then say plus, we can see that no service is added to this current scenario. Now I've got two options. I can go in and I can look at sample scenarios, which are going to give me sort of suggested costs and build for certain workloads. And you can see we've got dev test labs, common infrastructures, 50 protected virtual machines being replicated to on-prem or Azure, remote app solutions, and so on. Okay, so I can go in and I can view these, find out what's needed. Let's move over to this one maybe. So if I go into view this, what's involved, so we can see there's the backup solution in there, the storage transactions, the page blobs and disks that are needed, the virtual machines, how many instances we want. So I can go ahead and I can choose to add that into my cost estimate. But what I want to do is I want to be more granular. So I'm going to come across to where it says services. And then from there, you can see that we have the option to go into compute, web and mobile, data and storage, analytics, and so on. Under compute, we can see that we have a second tier of options to choose from. I'm going to choose virtual machines. So under virtual machines, I'm going to choose that I want to go Europe West. I want to choose a DV2v2 machine. I want it to be on a standard tier running Windows, and I want one instance running continually, so 744 hours. From here, I'm going to give it a description and call this the domain controller. Okay, so with that done, I can choose to add that into the Azure Dan demo and then move over to data and storage. Now we know when we create a virtual machine, we also need to account for storage. So it's going to be a page blob and disk. Again, I want that to be in Europe West, and I want this to be geographically redundant. I want it to be, I don't know, let's say 350 gigabytes. Okay, so it's going to be the DC disk, and I can go ahead and I can add that into the Azure Dan demo. From there, perhaps I want to be able to connect into it. So maybe I want a VPN gateway. If I go ahead and say VPN gateway, I want that hosted in Europe West. I want it to be a standard VPN gateway. It's going to be running for 744 hours. Okay, so it's going to be VPN gateway to Azure DC. And then from there, I can go ahead and I can add that to the solution as opposed to outbound VNet data transfers. I can go ahead and say, right, well, that's going to be Europe West, Zone 1 for US, Europe, and so on. I'm going to say that it's going to be a terabyte of outbound data. And again, I can go ahead and add that to the scenario. Now, if I come back to my cost estimate, you can now see that under Azure Dan, it's starting to give me a breakdown of all of these services. Okay, if I go ahead and then save that, I can generate a cost estimate Excel spreadsheet. So if we go in, if we say this is going to be Azure Dan demo, and then from there, we'll just open this up and you can see that we can get a breakdown of all of the components that we've specified. In the following section, we will learn about the Azure Pricing Calculator and price a solution for our sample case study. The Microsoft Azure Pricing Calculator comes in two flavors: the public calculator, which aligns to direct web costings, and the channel pricing calculator for partners, which is secured by a login, aware of channel pricing, and accommodates for markup to estimates. Both tools are aligned to Azure categorization and allow custom naming and exporting to Excel spreadsheets. Let's jump in and take a look. Okay, so before we jump into our case study, let's just get familiar with the pricing calculator. So I'm in azure.com under pricing. In the pricing calculator, let's go ahead and add some items. And again, I want to keep this really simple, so I'm going to add some compute. I want a virtual machine. Virtual machine obviously needs some storage, so we'll add some storage. And I want to go down and add a VPN gateway that will allow us to connect in. As we come down, as we said before, I'm able to customize these. So I might say, Azure Dan Demo VM. It's going to be a West Europe machine running Windows. The pricing tier is going to be standard. And I think we'll go ahead and make this a D2V2, so 2 cores and 7 gig of RAM. It's going to be 2 virtual machines running continuously. Okay, with that done, we need some storage for these guys. So let's say West Europe. We're going to choose page, blob, and disk. Pricing tier, let's leave as basic, and we're going to make this geo-redundant. And for the 2 machines, let's say that they're going to be 320 gig each, so 640 gigabytes. And for storage transactions, this is based on 1 unit being 100,000 transactions. So, let's just say 500. Okay. You can see that the price is nominal. Okay. If we scroll down, if we look at a VPN gateway, if we say we want this to be in West Europe, we're going to choose a basic VPN because we're only connecting to a single machine. This is going to be on constantly. And if we come down, it's going to be standard VPN. And we're expecting, let's say, 750 gigabytes of data a month. So with that done, we can see that the running cost for that machine with the storage and the VPN gateway with the outbound data, okay, is going to be £364. I'm sorry, that's for 2 machines, isn't it? So that's 2 computers with the storage and the gateway and the bandwidth, £364. If we look at the export estimate, we can then go ahead. That downloads into an Excel spreadsheet. And again, that gives us a breakdown of what's required. So in our final section, we will take what we have learned and apply this knowledge to a simple case study. Contoso is a small born-in-the-cloud manufacturing company that wishes to build its computing platform in Azure. They also wish to be able to establish a connection from remote locations that will allow data to be shared securely. In this exercise, we will price the network, virtual machines, storage, and egress data using the public calculator. So as we begin pricing our solution, let's make the following assumptions. We're going to assume that all services are going to be hosted in North Europe, that the company wishes to use a single D2V2 virtual machine for a domain controller. Now, the company is aware that this is not best practice, but have decided on this configuration regardless. We're also going to price 2 D4V2 VMs, which are going to be used as application servers. The operating system disks are going to be 128 gigabyte P10 SSDs, and we're going to have 2 application disks totaling 4,096 gigabytes, which is going to be geo-redundant storage. We're expecting 2 terabytes of egress bandwidth for the application, as well as 500 gigabytes of outbound VNet traffic for our VNet connections. All of this will be tied in with a basic support contract. So let's begin. Okay, so from our pricing calculator, let's go ahead and add items. We want to go ahead and add the compute. So once for the domain controller and once for the application servers. If we then come down to data and storage, we're going to add 2 storage accounts, one for the SSDs, one for the application server data disks. We then want to come down to networking. We want to establish a VPN gateway, but we also want to specify for that 2 terabytes of bandwidth. Okay, so we'll click on the 2 terabytes of bandwidth. Okay, with that done, let's begin configuring it. Now, we said that all of these are going to be hosted in North Europe. So let's say North Europe. So for our virtual machine, North Europe, type Windows, pricing tier standard. And this first machine was going to be a D2V2. So a D2V2 is going to be a single machine that's continuously running. If we scroll down, we want to then select North Europe for our second bunch of machines. These are going to be D4V2, so 8 cores and 28 gig of RAM. Okay, we want 2 of these machines. If we then continue to scroll down for our storage, for our SSDs, North Europe, they're going to be page blob and disk. The pricing tier is going to be SSD, and we can see we've got P10, the 128 gigabytes. Now we want 3 of these, so we'll select our 3 disks before coming down and selecting our second storage. So again, North Europe, this is going to be page blob and disk, but this time we just want a basic disk, which is going to be geo-redundant, and we said that the combined total of both of those is going to be 4096. Okay, in terms of storage transactions, again, let's just be overly conservative, and we're going to put in 5,000, which is going to come into £11 a month for us. For the VPN gateway, if we say that that's going to be North Europe, it's going to be a basic VPN, and we expect that to be continuously running. Okay, in terms of the outbound traffic, because all inbound is free, we're going to expect 500 gigabytes so we can connect into that machine if we need to. And in terms of bandwidth for the application, if we then say North Europe, and we want to expect about 2 terabytes. So if I come down into terabytes and we change that to 2, that gives me my overall price. So we can see that our estimate is coming out at £1,463.31. Okay, from there, if I go into the support options, you can see that we've got the basic, which is included, but we could then go into developer, standard, or professional direct. Okay, from here, let's export our estimate. And we'll allow that to open up in Excel. And then what we should have is a nice breakdown of the running costs of that VM solution per month. In this video session, we have looked at how to size and price an IaaS solution in addition to understanding the technologies involved. As we wind down the course, I would ask you to remember the following key takeaways. Firstly, virtual machines are billed on a prorated minute. Secondly, you pay for a VM when it's in an allocated state. Even a shutdown VM can still be allocated and therefore billable. Ensure the VM is deprovisioned. Thirdly, when pricing, remember all storage other than the volatile temp disk is billable. And finally, always account for egress data when calculating costs. If you are interested in beginning your own cloud journey or building on top of the systems already in place, then I would encourage you to take my free step-by-step training series at www.cloudandproud.info. Working together and over the course of a number of interactive sessions, we will build a working company and explore many of the new features offered by the Microsoft Cloud. This will in turn prepare you for certification and build confidence in what you're able to achieve. I thank you for taking the time to view this training session today. I hope it's been useful and look forward to seeing you on the next one.